Hello everyone. Welcome to my YouTube channel on engineering mathematics. In this video, I am going to discuss a numerical technique named Gauss Jacobi's method. We will also discuss a couple of examples based on this method. So let us first see concept overview. It is a numerical iterative method to solve system of linear algebraic equations of these types. This is a system of linear equations in three variables x, y and z. Solution obtained using this method is always approximate in nature and close to the exact solution. Now, before proceeding for the method, I would like to make some assumptions. The very first assumption is the given system of equations Ax is equal to b has a unique solution. The second assumption is the coefficient matrix A has no zeros on its main diagonal, namely A11, A22, A33 and so on. That means at these positions, we should not have zeros. Also, these coefficients should dominate the other coefficients in the equation. Note that if any of the diagonal entry is 0 or they do not dominate the other coefficient, then we should interchange the rows or columns to obtain the coefficient matrix that has non-zero entries on the main diagonal, or these diagonals should dominate the other coefficients. Now, let us see steps involved in this method. The very first step says, write the system in the form shown below. So assume this is the given system of equation in x, y and z. Then we write or modify this system as follows. We write x in the form of y and z from equation number 1 like this. We write y in terms of x and z from equation number 2 like this. And then we write z in terms of x and y from equation number 3 like this. We call this new set of equations as equation number 1. In step 2, we assume the initial approximate solution be 0, 0, 0. That is x is equal to 0, y is equal to 0 and z is equal to 0. Note that this is just an assumption. We are nowhere close to the exact solution. Okay, then in step 3, for the first iteration, that is to find the first better approximate solution, we substitute this assumed solution, that is 0, 0, 0, in the equation that we got from step 1. So when we do so, we will get new solution, say x1, y1 and z1. So these were the equations from equation number 1. When we substitute y is equal to 0 and z is equal to 0, we will get better approximate solution for x. We say it is x1. So x1 will be b1 by a11. Similarly, when we put x is equal to 0 and z is equal to 0 in equation number 2, we get better approximate value for y, say it is y1, which is b2 upon a22. Similarly, after substituting x and y 0 in this equation number 3, we get the better approximate solution for z, say z1, as b3 upon a33. So this is the first better approximate solution that we got after substituting our assumed solution 0, 0, 0. Now in step 4, we go for next better approximate solution. For that, we will substitute this new solution x1, y1, z1 in equations 1 to get better approximate solutions, say x2, y2 and z2. So look at here, these were equations from equation number 1. When we substitute y is equal to y1 and z is equal to z1 over here, we get better approximate solution for x, say x2. So this will be your x2. Same thing we do for y and z to get y2 and z2. Now in step 5, I say we continue these iterations to find the solutions until we reach to the desired accuracy. Or if the solution in 2 successive iterations matching up to 4 decimal places, we stop finding next better approximate solution and we say that the latest solution obtained is the correct solution up to 4 decimal places. I hope you understood these steps. Now let's use these steps for solving some real examples. So next is our real example. In this example, we are asked to solve the system of equations using Gauss Jacobi's method. So this is the system of equation. I see this is system of equation in 3 variables, in 3 equations. Now let us go for solution. Before going for step 1, we have to see that if we write the given system in terms of Ax is equal to B form, then in this coefficient matrix A, all the diagonals should be non-zero as well as they should dominate the other coefficients in the row. So I see these coefficients along the diagonal are non-zero as well as they dominate the other coefficients in the row. So yes, the condition is fulfilled. Now we can proceed with step 1. According to step 1, we have to write these equations in a special form. We have to write x in terms of y and z from equation 1, y in terms of x and z from equation 2, and z in terms of x and y from equation number 3, like this. So you see that x is equal to 13 minus y minus 2z upon 10. Y is equal to 15 minus 2x minus 3z upon 10. And z is equal to 14 minus x minus 3y upon 10. We call these equations as equation number 1. Now let us go for step 2. In step 2, we have to assume the initial solution to be 0, 0, 0, like this. Now, for finding next better approximate solution, we substitute these solutions in equation number 1. Values so obtained after the substitution, I am going to put in a tabular format so that you will understand in a better way. So let's go ahead with the table. So this is the table that we have to form. The column headings will be iteration number, x in terms of yz, y in terms of xz, and z in terms of xy equations. These will be our iteration numbers. You can increase the number of iterations as you want. Now, at iteration number 0, initially we have assumed our x, y, and z to be zeros. Now, as per step 3, we have to substitute y is equal to 0 and z is equal to 0 in the expression for x. So when we put y is equal to 0 and z is equal to 0, we get better approximate value of x, say x1, which is 13 upon 10. That is nothing but 1.3. Similarly, we put x is equal to 0 and z is equal to 0 in expression for y. We get y is equal to 15 upon 10, which is 1.5. We do the same thing over here. We put x is equal to 0 and y is equal to 0. That is these values to get z is equal to 14 upon 10, that is 1.4. Now for next iteration number 2, in expression for x, we put y is equal to 1.5 and z is equal to 1.4. So we get x is equal to 0.87. You can keep your calculator handy and you can do this calculation and cross check. Now for y value, we will put x is equal to 1.3 and z is equal to 1.4 here to get y is equal to 0.82. Similarly, for z value, we put x is equal to 1.3 and y is equal to 1.5 to get z is equal to 0.82. Now for next iteration number 3, we put y is equal to 0.82 and z is equal to 0.82 in this expression. So we get x is equal to 1.054. Here for y value, we put x is equal to 0.87 and z is equal to 0.82 to get y is equal to 1.08. Next, we put x is equal to 0.87 and y is equal to 0.82. We get z is equal to 1.067. For next iteration, we put y is equal to 1.08 and z is equal to 1.067. In this expression, we get x is equal to 0.9786. Here we put x is equal to 1.054 and z is equal to 1.067. We see y is equal to 0.9691. Similarly, after substituting x is equal to 1.054 and y is equal to 1.08, we get z is equal to 0.9706. On the similar lines, we find further values of x, y, and z in iteration number 5 and 6. We see those values are these. Now we see that in iteration number 6, value of x is 0.99640, value of y is 0.994783, and value of z is 0.99517. So we see that these values are approximately x is equal to 1, y is equal to 1, and z is equal to 1. So let us see whether 1, 1, 1 is the solution to this system of equation. To cross check it, you just have to substitute those values of x, y, z in each of these equations, and you have to check whether these equations are satisfied or not. So let us check this first equation. When I put x is equal to 1, y is equal to 1, and z is equal to 1, I get 10 plus 1 plus 2 is equal to 13. Yes, so this equation is satisfied. Similarly, if I put x, y, and z as 1, 1, 1, we get 2 plus 10 plus 3 is 15. That's correct. This equation is also satisfied. Similarly, here when I put values of x, y, z, I get 1 plus 3, 4 plus 10 is 14. So this equation is also get satisfied. So we say that solution to the system of equation is x is equal to 1, y is equal to 1, and z is equal to 1. I hope guys you understood this method of finding system of linear equations solution using iteration technique. Let me show you one more example of the similar kind. Question remains same. We have to solve the given system of equation using Gauss Jacobi's method. Here we are given three different equations. Before proceeding to the solution, we have to cross check that whether all the diagonal elements of matrix A are non-zero and are they dominating the other coefficients. So let's check it. Here first equation's diagonal element is 15. It is non-zero as well as it dominates other two coefficients. Here also in second equation diagonal element is 15. It is non-zero and it dominates other two coefficients. Same thing happened with the third equation. Diagonal element is 15 and it dominates other two coefficients. So condition is satisfied. Now we can proceed with this solution. As per step 1, we have to write the given equations in a special form. From first equation, we have to write x in terms of y and z. From second equation, we have to write y in terms of x and z. And from third equation, we have to write z in terms of x and y. We call this new set of equations as equation number 1. Now in step 2, we have to assume that the solution to the given system of equations is 0, 0, 0. We have to substitute this solution into the equation number 1 to find out further better approximate solution. Now at this point, we are going to write the calculations in a tabular format. So let's draw this table whose first column is iteration number. Second one is the value of x in terms of y and z. Third one is value of y in terms of x and z. And fourth one is the value of z in terms of x and y. At iteration number 0, we assumed value of x, y, z to be 0, 0, 0. We substitute these values of x, y, z into these equations to find out further better approximate values of x, y, z respectively. So when I put y is equal to 0, z is equal to 0 in this equation, we get next better approximate value of x as 17 upon 15, which is 1.1333. Please keep your calculator handy so that you can cross check these calculations. Similarly, when I put x is equal to 0 and z is equal to 0 in this equation, we get y is equal to 18 upon 15, which is 1.2. Next, we put x is equal to 0, y is equal to 0 in this equation. We get z is equal to 18 upon 15, which is once again 1.2. Now for next iteration, we assume x value as this, y value as this, and z value as this. We substitute these values of x, y, z over here to get their better approximate values. I'm just scrolling down those answers. You can pause the video and cross check these calculations. Please write me in comment box whether these calculations are correct or not. So I have made calculations up to 5 iterations. I see that the solution in third and fifth iteration is almost similar up to 2 decimal places. And this thing is repeating itself. So we stop finding further values of x, y and z, and we say that x value is approximately equal to 1, y is approximately equal to 1 and z is approximately equal to 1. Let us cross check whether this 1 comma 1 comma 1 is solution to these equations or not. Substitute x is equal to 1, y is equal to 1 and z is equal to 1 in all of these equations. We see it is 15 plus 1 plus 1, it is 17. Yes, this equation is satisfied. Coming on to second equation, 2 plus 15, 17 plus 1 is 18. This equation 2 got satisfied. 1 plus 2, 3 plus 15, 18. Yes, this equation also got satisfied. We say that x is equal to 1, y is equal to 1 and z is equal to 1 is solution to the given system of equation. I hope guys you understood this example also. Now I have set of practice examples for you. Their final answers are also given here so that you can cross check your solution. Please write me in comment box whether you understood this Gauss Jacobi's method for finding solution to the system of equations or not. In my next video, I'll be coming with new method called as Gauss-Seidel method for finding solution to the system of equation. Till then, keep watching my videos. Thank you all of you. Thank you for watching this video. Please subscribe my YouTube channel and press the bell icon to get updates about my new videos.